The historic freeze, the causes of the ice ages. Hello, everyone. When we picture an ice age, we think of massive glaciers, cold temperatures, and iconic life like the mammoth. But the real query isn't just that they happened, it's why they happened. Ice ages, periods where massive sheets of ice cover the Earth, are caused by a fascinating slow connection between Earth's orbit, its geography, and its atmosphere. To get the cause, we need to mix the factors into two groups. First, the long term factors, the slow forces that set the stage for an ice age to be possible. Second, the short term factors, the rhythmic, astronomical changes that act as the trigger starting and ending the glacial cycles within that ice age window. The first key to an ice age is the position of the continents. Excuse me. Our planet can't really sustain a major ice age unless certain conditions are met, and that's a geological condition. If large continents are positioned near the poles like Antarctica is today, and North America and Eurasia are close to the Arctic, it all it allows ice sheets to grow without melting in the summer. When continents drift away from the equator and block the flow of warm ocean water, global ocean currents shift. For example, the formation of the Isthmus of Panama about 3 million years ago helped set the stage for the current ice age by rearranging ocean circulation. The second long term factor is the overall amount of carbon dioxide in the atmosphere. Over geological time, the amount is regulated by volcanoes and the slow chemical weathering of silicate rocks. For an ice age to occur, the background levels needs to be low enough to allow global temperatures to drop. If we have super high temperatures like we did millions of years ago, ice sheets simply can't form no matter how the continents are arranged. Now, for the trigger. The cycles that actually cause the ice sheets to grow and shrink are known as the Milankovitch cycles, named after Serbian scientist Milutin Milankovitch. These are rhythmic, predictable changes in Earth's orbit and tilt that affect the amount of sunlight or insolation reaching the planet. Critically, these cycles matter most at high latitudes during the summer. No ice ages don't start because of brutally cold winters. They start because the summers aren't warm enough to melt the previous winter's snow. If the snow doesn't melt, it piles up, compacts into ice, and a glacier is born. The three main cycles are eccentricity. This is the shape of the Earth's orbit around the Sun, which changes from nearly circular to slightly elliptical over a cycle of about 100,000 years. This differentiates the amount of solar power Earth receives. Number 2, axial tilt. This is the angle of the planet's tilt, which varies between 22.1 and 24.5 degrees over a period of 41,000 years. A smaller tilt means less major seasonal differences, making it simpler for the snow to survive summer at high latitudes. Number 3, precision. This is the slow movement of the Earth's axis over a 26,000 year cycle. This changes when we are closest to the sun during the seasons, massively affecting the severity of summers and winters. The final punch, feedback loops. Once the Milankovitch cycle move the climate cold enough, feedback loops take over. The strongest one is the ice albedo effect. Ice and snow are shiny and reflective. As high sheets grow, they reflect more of the sun's energy back into space. This causes the planet to cool further, which allows more ice to grow, which causes more reflection, and the cycle accelerates itself into a deeper glacial period. These feedback loops are what truly make the Ice Age powerful. In summary, ice ages are complex. They require a long term geological setup, continents at the poles, followed by the astronomical timing of the Milankovitch cycles to act as the primary trigger. It's a spectacular demonstration of how seemingly small changes in our planet's motion shape, re, can profoundly reshape the entire global climate.